The interrupt is a signal that stops the normal execution of a program and starts the function assigned to a specific source of this interrupt. The function executed is Interrupt Service Routine, in short ISR, or Interrupt Handler. The ISR can be recognized as a task with higher priority than the main program. Interrupt signals can be generated by the external source, like a change of value on the digital pin, or by the internal source, from a peripheral module like a timer, serial port, analog to digital converter, or any other built-in peripheral device. When the processor receives the interrupt signal, it stops executing the code and starts the ISR. Of course, a different handler is called for a signal coming from serial port, which differs from the pin state change. It is the interrupt controller that tells the processor which ISR to call. After completing the interrupt handler, the processor returns to the regular program execution. The interrupt routine should be as short as possible. Although it is not forbidden to use delays, good practice is to avoid long code sequences, loops, and delay functions. Sometimes writing too long interrupt handlers causes the system to hang up or even restart. Suppose there is a need to trigger the execution of a long part of the code with an incoming interrupt signal. In that case, the good practice is to define the synchronization variable, modify this variable in the ISR with a single instruction, and handle all other steps in the main program. This approach keeps the interrupt handler very short. To ensure fast program execution, some Arduino functions do not work or behave differently when used inside the interrupt routine. For example, the delay function doesn't work inside the ISR. Variables used in the ISR must be declared volatile. The interrupt handler doesn't have arguments and doesn't return any value, so its type is void. The use of interrupts can help in efficient data transmission. While the program waits for the pin state change or for incoming data from serial port, the processor needs to periodically check the situation. Such an approach is called polling. While using interrupts, the periodical check is unnecessary. The interrupt handler is executed only when needed, after receiving the hardware signal from the peripheral module. This approach saves the processor time and in many situations makes code energy efficient. Using interrupts requires support from the hardware and the programming framework. The availability of interrupts assigned to a specific peripheral strongly depends on the microcontroller. In Arduino, interrupts can be used to handle state changes on digital inputs. The function attachInterrupt is called to attach an interrupt input pin to the handler. It has three arguments. First, pin. This is the pin number which works as the interrupt input. Second, ISR. This is the name of an ISR function. In fact, the address, or in other words, the pointer to the function. We described this mechanism in the subprograms section. And the third is mode. Defines the situation when an interrupt signal is triggered. There are 5 fundamental mode values. Low. Interrupt is triggered when the pin value is low. High. Opposite. Interrupt is triggered when the pin value is high. Rising. Interrupt is triggered when the pin value changes from low to high. Falling. Interrupt is triggered when the pin value changes from high to low. And change. Interrupt is triggered when the pin value changes in any direction. In the example, we will write the program that changes the state of the LED connected to the digital output every time the button is pressed, of course using interrupts. In the setup function, we define 2 pins, one for input and one for output. For the input pin, we activate the internal pull-up resistor. The button ISRs function is our interrupt handler. It will be called every time the button is pressed. We need to attach this function to our pin to ensure such a behavior. The button toggle variable will pass information from the interrupt routine to the main program. It must be declared volatile to ensure synchronization of its value between the main program and ISR. We use the button toggle variable in the main loop to control the output pin. We could perform this action directly in the interrupt routine, but here we want to show the method of passing information from the ISR to the main program. This is an example of the good practice of writing an interrupt handler as short as possible.